All right, guys and girls, welcome back to our ACT video help series. And we're talking about question number 24 on our ACT practice test. So, what it tells us to do is to convert 40 degrees to radians. And what we have here is something very similar to what we had with number 10 on the practice test. This is another unit conversion problem. And remember, what we are looking to do is to convert basically an angle that is about this size, about like this. This is 40 degrees. And what we would like to do is convert that to an equivalent measure in radians. Well, what's a radian anyway? Well, with this circle, it has a radius. Every circle has a radius. It's the distance from the center to the to the circle itself. So the every point on the circle is the same distance from the center. So if we were to start here and we were to turn about one radius, this angle is 1 radian. Why? Because it is the measure of the arc that is equivalent to 1 radius. So when we measure in radians, we're measuring on the basis of 1 radius being the standard unit of measurement for arc. Okay, so then we would come around here. We would have perhaps another radius like this. Then we would have another radius would come in here like this. And as expected, this would be pi radians right there. So a little bit more than 3 radii. Then another radius, and we come in right here. And then we have another one, maybe right through here. And then we have another one kind of through here. And then we have a little bit left over. And this is about 0.28 r. So how many radiuses are there around the edge of the circle? Well, it's more than 6 and less than 7, right? So it's somewhere between 6 and 7 radiuses. So for those of you keeping track of how many times Dr. Mack has 6 7, there's one more for you. Okay, so now we know that 1 revolution is equivalent to 360 degrees, and that is equivalent to 2 pi radians. So 2 pi radiuses go around the edge of the circle, so we have 2 pi radians if we're using that as the measure for a unit of measurement for how far we've gone around the circle angularly. So we now have that to work with. So if 360 degrees is equal to 2 pi radians, we would have 180 degrees equal to pi radians. And now that gives us a really nice, convenient way to do unit conversions. Is now we know 180 degrees is equivalent to pi radians. So what do? We multiply 40 degrees. So we're going to multiply 40 degrees by a unit conversion factor, and remember this one has to be a factor equivalent to 1. And since 180 degrees is telling me it's a semicircular arc, and pi radians is telling me that it's a semicircle arc, I'll just put something with the degrees down here in the bottom, and I'll have 180 degrees, and then that is equivalent to pi radians. And we just need to simplify now. So we would have the degrees cancel out, and we would have something in radians. So we would have 40 times pi over 180, which is 4 pi over 18. Of course, this is radians. This is radians too. But if I cancel the 2 top and bottom, I get 2 pi over 9 radians, which is exactly what our correct answer choice was in that problem. So now we know how to do that unit conversion. It's just like any other unit conversion. We're just converting from one system of measurement for angles, degrees, based on the full revolution being 360 degrees, which has been the standard way of dealing with things since the days of the Babylonian Empire, where they used a lot of base 60. So 60 seconds in a minute, 60 minutes in an hour, or 60 and 360 degrees in a circle. That all comes from the Babylonian Empire. And we are just doing the same unit conversion process as we used in problem 10. And that's how we work with degrees and radians. That's how we measure angles. That's all I've got for right now for this video. Thanks for watching.